Also, as a reminder, for more Microsoft webcasts, you can visit microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Windows Communication Foundation, top to bottom. Today's session is part 12 of 15, Reliable Messaging. And now, without any further delay, I'm going to turn the floor over to today's presenter, Michelle LaRue Bustamante.
Thank you, Tracy. Welcome, everybody. So here we are with part 12 of 15 on reliable messaging. And once again, my name is Michelle LaRue Bustamante, and I am an architect with iDesign. You can see our information at iDesign.net, and I'm a Microsoft Regional Director for San Diego. So I recently finished a book called Learning WCF, so I've been working pretty closely with some of the product teams on that stack in obviously preparation to complete the book and so forth, and also as we work with our clients. And you can get all of the code that I wrote for that book, Learning WCF, at thatindigogirl.com, which is a URL you see at the bottom of this page here. And at that site, again, the demonstrations that I'll be showing today are sourced from that book. And of course, if you're looking for anything specific, you're always welcome to email me. I may have other samples that are hidden around somewhere. And then at dosblon.net, I also post other information on WCF and related subjects like card space and federated security. So you might want to take a look there as well. And to continue, what we'll be talking about today is Windows Communication Foundation, the implementation of the reliable messaging standards within the platform in order to give us a level of reliability beyond what we get with transport protocols. So we're going to talk about the underlying architecture and how that works, and I'll explain that visually so that you get a perspective. We'll talk about the bindings that support this protocol, talk about some scenarios where it would be useful, and then how to deal with certain things like sessions and timeout exceptions, and demonstrate recovery with actual failed messaging. So the prerequisites for today, given that we are on part 12 of 15, what I expect is that you've got experience building .NET Framework applications and that you have a basic understanding of WCF, how to build a service, how to host it, and how to consume it with a client. And of course, binding configurations. In terms of does security relate to this particular discussion? No, so you don't really necessarily have to have a background in every webcast that I've put on. I would say you want to get through webcasts 1 through 6 before you get here. Now, in terms of the agenda, the order I'll go in, we'll talk about the reliability features in general for WCF. Then I'll talk about binding support for reliable sessions specifically. We'll talk about the architecture and how that looks. I'll get a little bit into the standards to give you a perspective on how those work. And then we'll talk about some specific details like how do you require bindings to support reliable messaging and order delivery, how do we deal with sessions, timeouts, exceptions, and then how do we configure custom bindings to control more detailed settings in reliable messaging. So let's start with just the basics. In any system, when you have distributed components, distributed services in this case, you definitely need some level of reliability whereby if a service is living on another machine and or across a firewall and or across boundaries of clients and industries and customers and corporations and so forth, we do need to somehow have a dependability in the communication between those machines across those networks or even across the internet. And the idea is that accessing remote functionality in an application is never easy because you are definitely potentially going to have problems related to connectivity. The network can go down. You can have a hiccup in network connectivity. You might be on a modem still in some countries whereby the reliability of the line is just not there. But there's really no reason for an interim hiccup in connectivity to completely derail the communication between the client and the services or components it's trying to talk to. To gain some level of predictability then that functionality got executed, to make sure the system is available, left in a consistent state, and to depend on network connectivity, we have some features in WCF that collectively make it possible to build reliability into your systems. And the first of these is reliable sessions, and that'll be the first one I discuss today. But there are other features such as transaction transactional programming, and also queued messaging that support reliability as well. So overall, these are ways to guarantee consistency, guarantee messages arrive to the door, and also survive potentially even machine down conditions when we talk about queued messaging. Now for today, like I said, I'm going to focus on reliable sessions and what those will help us with specifically. And then we'll get into the other two in the next two webcasts, which I'll be doing next Tuesday. So reliable sessions make it possible to withstand any sort of hiccup in network connectivity. So a transient interruption whereby the network sort of just has some sort of glitch, but then it comes back online quickly. We're not talking about hours of downtime, and we're not talking about machines that actually go down and then come back up, so a reboot. We're talking about potentially intermittent hiccups, and or maybe even at the application. So what reliable sessions gives us is the ability to, in this transient way, overcome some sort of interruption and provide some level of delivery guarantee whereby we know that a message was delivered to the application exactly once, and if you desire, in order. So if you wanted messages to arrive in a particular order, that's also possible. Now this is all independent of the transport protocol. So the idea of reliable sessions is, even though TCP gives you a level of reliability in that there are acknowledgments that come back for every message that is sent, for example, it's not end-to-end reliability. It only takes you from point to point. And we've talked about the difference between point-to-point and message-based protocols in earlier webcasts related to security, in the sense that when I send a message from my application to a proxy server, that's point-to-point. So then the proxy server would be responsible for, once again, having reliability between it and perhaps the web server that it is sending the message to. And likewise, on that web server, there could be an application router that's then responsible, once again, as a network node to send the message to another part of the application. And so those separate points are responsible for their own reliability, one after another. And of course, if one of them is using HTTP and the other is using TCP, then the level of reliability isn't really guaranteed all the way through, is it? When we use message-based reliability, then you get the ability to have application-based reliability, meaning the guarantee is that it actually arrives to its ultimate destination, which is the application or service that you wanted the message to get to. And this type of protocol based on message is actually a web service protocol called WS Reliable Messaging. I'll talk about that a little bit in a short while. And it's interoperable. So the idea would be I could have a Java node and a .NET node that communicate reliably, independent of the protocols we use for transport. So reliable sessions gives us delivery guarantees. We know the message got to its destination, and we can guarantee in order. Now, how long is the guarantee? Of course, it's transient. We're not talking about guarantees forever. We're talking about the potential of retrying sending a message in order to give it a better chance of succeeding if there was a hiccup in connectivity. So we'll talk about the details of that. Now, in terms of when can I use reliable sessions, when can I enable this feature that takes me beyond just transport reliability? And that is using the following bindings by default. That would be NetTCP binding, WS HTTP binding, which is your advanced web service binding. You've got dual HTTP binding, which is always using reliable messaging because that's how we guarantee the two-way communication and ordered messaging. And then we've got Federation HTTP binding, which is really a special binding for security that I briefly talked about in our last webcast, but it's a lot like WS HTTP binding in that it supports the emerging, more recent standards in web services. So the idea is that with NetTCP binding, even though TCP has acknowledgments and can help to replay messages when we have some sort of connectivity issues, the reliable messaging approach actually is more consistent and gives us end-to-end reliability. So it's also still useful to turn that on for TCP. Now when we talk about web service HTTP binding, or any of the others listed here. We're talking about adding reliability to HTTP protocol, which is a great thing, because we don't have that sense of acknowledgement and retries by default. Now, in a custom binding, which you know that we use when we can't get all the features we were looking for in a particular standard binding, with a custom binding you can also configure reliability, and actually there will be times that you might want to do that, and I'll show you that a little bit later. But for now, let's just talk about how do I enable reliable sessions for a binding before I give you a demo. So if I'm using TCP, if I want to enable message-based reliability or reliable session, then what I do is I add a custom binding. So this is a custom binding or configuration for NetTCP. And I'll enable reliable sessions by setting the reliable session property to true. Now, ordered is already true by default, and the inactivity timeout, which I'll talk about what that means shortly, is 10 minutes by default, but enabled is false by default. So we have to opt in to turning on reliable session for this binding. For WS-HTTP binding, it looks much the same. So there's a reliable session section in the config. You have to enable it, and then the default otherwise is ordered as true and 10 minutes for session inactivity. You can also enable it programmatically. When you construct the binding, NetTCP has a property or a parameter for setting the reliability to true. So the second parameter to the constructor in both cases will enable reliable sessions. And then, of course, you add your service endpoints programmatically, open the host as usual, and this would give you an initialized couple of endpoints that both support reliable sessions. So with that, let me just actually give you a short demo on enabling sessions and also on seeing them at work. So I'm going to share my desktop here and go through a quick demonstration. So let me just open up the correct demo here. And what you should see here is that I have a messaging service, and the messaging service has a send message and send message one way, so two different operations. The implementation is just going to write to the console, so we will see when the message gets there. Now, when we host this, I'm going to host the messaging service over HTTP in this case. And the binding that I'm using is WS-HTTP binding. Right now, the WS-HTTP binding is using the default settings, which is enabled as false. So we don't have reliable session just yet. The other thing I want to point out is I'm using this listen URI, which is saying, look, the actual service endpoint is at localhost 8000. That's the port that I'm opening, and normally we would see that address here in the address space. But what I'm doing is I'm allowing messages to be sent to port 8080 so I can turn on TCP trace and intercept the messages. So let me illustrate just by running an example here, and I'm going to go ahead and run the client and the service. And what's going to happen when I hit send is I've got some messages in here so that when you run this, you'll have success as well. And it's going to remind me to turn on TCP trace. So I'm going to load up TCP trace, and I'm going to listen on port 8080 and forward to port 8000. And I'm going to now be able to send messages. So here's my TCP trace in the background here. And my client is going to send a message, and you can see that it got there. And I've got now another dialog saying, if you want to test failure, turn off the trace session. But first, let's have some success. So I'm going to go ahead and send it successfully. We sent 3 messages using the same proxy, which is the equivalent of a session if you were to have sessions enabled. Let's go ahead and send this again. TCP trace is on, but now before I send message 2, what I'm going to do is I'm going to stop tracing. And let's go ahead and try to send the next message. And of course, right now, we're going to get an endpoint not found exception pretty fast. because right now it's trying to send to endpoint at port 8080. Port 8080 is not alive because I turned off the trace. And I didn't get much time to go back and turn on the trace again, did I? So we got the exception very quickly. Now let's see what happens when I actually enable reliable sessions. So what I'm going to do is set enable to true. And at the client, we'll do the same. So let's go into the client configuration, and we will set enabled to true. And I'm going to run the same demo. So the service and the client are running. Let's take a look at trace and see that we're running. So we'll start the trace. I'll bring the host forward here, and I'll bring the client forward here. And we'll call send again. So we're about to call the service. Great. Now what I'm going to go and do is I'm going to stop the trace for a moment and then try to send the message. In the meantime, I'm going to restart the trace. And it ends up sending the message. So I was able to turn off basically the intermediary in the middle, which is our TCP trace, and simulate what would happen. Now let's try doing this with one-way. So I send a one-way message. Normally, I actually have no way of knowing if it successfully arrived at the destination, because even if a problem happens, I'm not going to get the exception because it's a one-way message. And so what Reliable Sessions gives us, which you'll see, is it's about to send the second message. I'll go ahead and stop the trace again, and I'll continue. And now I'm trying to send the second message. It's not arriving clearly. I'll start the trace, and then eventually it'll get to that third message box saying it's about to send the third message. What that should tell you is that until the message could be delivered to the service, at least to the channel, and get that acknowledgement that it arrived, Reliable Sessions blocked at the client so that it could make sure that that message at least got there before we went on to do the next message. So even though it's one way, and even though once it arrives to the service, an exception could happen that I won't know about until I check that the channel hasn't faulted, for example, I will at least know that it arrived to the server, and that's the guarantee I'm looking for. And again, the whole idea of one-way messages is that I shouldn't probably care if an exception happens, because obviously the service has designed this operation so that it's one way, that we don't care about exceptions, and maybe they give a different way for us to report on results. So I'm using TCP trace on the same machine here to illustrate a point. And that point is that you can tear away, in a way, the network. In this case, I'm using the port 8080 of the TCP session as the network. But that's not so easy it doesn't actually work if you're using TCP binding, for example. So what I'm also going to do here, and you'll just have to believe me when I say this, I'm going to my other machine, which is on my network here, and I'm actually going to start a host which is remote, so it's on another machine. And I actually don't have Reliable Sessions enabled just yet on this particular demo, so I'm just running the host on my other machine. And what I'm going to do is I'm going to shut down this demo, and I'm going to open up a RM demo remote. So right now, again, my host on this other machine that's running is hosting the same messaging service that we just saw. And the client currently has Reliable Sessions set to false. So what I'm going to do is I'm going to run the client. And the client is going, just to prove it, to my MLB Vista machine. So it's another machine. And I'll go ahead and send a message. And it's about to call the remote service. And it's about to send a second message. And so what I'm seeing that you're not is that the messages are arriving to the service and everything's good. As far as one-way messages go, basically all those one-way messages were sent through as well. Now, I'm going to actually stop the client and stop the service. And I'm going to edit the service config first over here, which you're not going to see me do. And I'm going to enable reliable sessions. And then I'll go ahead and run the host. And actually, let me do something else real quick here. I'm going to, before I enable reliable sessions, what I had meant to do is also show you what happens when we disconnect without the reliable session. So let me just run that real quick again. Okay, so I'm actually continuing without reliable sessions here, and I'm going to send a one-way message, for example. It's about to call the remote service. The first one worked. I'm going to disconnect the network and click OK, and notice my other messages get through. I mean, basically, what happens is I'm not going to know if the message actually arrives to the service or not. I'm not going to get an exception until I try to, use that channel for a non-one-way message. Now let's try a two-way message, and I'll disconnect the network. And actually, I'm reconnecting the network, but it looks like we're hanging for a second, and the client channel is about to fault because it doesn't know how to resend the message. And I'm over HTTP right now. So it's not responding, and I get a channel timeout. So it's unable to get that message delivered. And this is a two-way message. Now I'm going to do the one-way message once again. Send one way, about to call the remote service. Let's just wait for that to connect. And because of the network, it's just sort of reconnecting the network over here, so that's happening on the other machine. Now I'm about to send a second message, but I'm going to disconnect the network, because the last time it actually looked like it didn't disconnect. And then I'll reconnect. And it's still going to try to send the second message and the third message. So basically, again, without, because it's a one-way message, we're not going to necessarily get notified of the issue until we try to call a two-way message, which will then say, hey, the channel has been faulted. Now let's see what happens when I turn on reliable sessions. And again, all I'm doing is setting reliable sessions to true on this other machine over here. And on the client machine, what I'm going to do is do the same. So let's go to reliable sessions and set that to true. And we'll run the client. So I'm going to go ahead and send, it's going to create a proxy. It's going to call the remote service. The first message gets through. I'll disconnect the network. It's going to try to send. I'm going to reconnect the network. I'm watching my other machine to see that it's recognizing the network is reconnected, but it seems to be taking a while to see that. And as long as it comes online in time, now we see it's about to send a third message. So that means it didn't fail, and it actually did send all three messages on the server, which I'm looking at. Sending one way, it'll send the first message. I'm going to disconnect the network again. Try to send, and notice instead of it going through the one-way message so quickly, because of reliable sessions being enabled, we're not going to see the dialog that says it's about to send a third message and close the proxy, because it's waiting to retry and make sure that that second message got safely to the server channel before disconnecting. And finally, it got there, and away we go. Now, what's interesting to look at is the messaging that happens in order to handle all of those retries. But the point you should take away from this example, and again, I just wanted to make sure I didn't only show you TCP trace, because that's one way to simulate network failure, but I wanted to show an example that actually goes to a remote machine. But when I turned on reliable messaging in both cases, it was able to retry and recover from the disconnect, whereas when I don't have reliable sessions, it will automatically, it'll fail more quickly, saying it can't find the endpoint. And by the way, this also works for trying to create the proxy and establish communication and session. So it will retry that as well. So let's talk about the architecture behind all this and why this works. So the idea is that, of course, WCF has a channel on the client and server side that are equivalent in order to communicate. And that channel is established with a reliable session if you enable it. And so what happens is there are these buffers that are created at both ends that help to manage the communication between the client and the server. As far as you're concerned, your proxy just sends a message. It just calls an operation. But underneath that, in the channel layer, it will actually buffer that message and wait for an acknowledgement that the message arrived to the server buffer, and then actually, once the acknowledgement has been received, take it out of the client buffer. So that way we always have the message available to resend. And so what happens is these delivery notifications are sent to the client channel. And anything missing in terms of acknowledgement triggers the client channel to, after some period, retry sending that message up to some configurable number of retries. Now let's take a look at how that looks in a picture. So the client channel will wait for acknowledgments. The server channel will enforce order if applicable. Let's see how that might work. So the client calls one or more operations on the proxy. So let's say it calls, operation and sends message 1 through 4 in that order. And so the client side channel will have a buffer for message 1 through 4. And we'll send the first message, which is then received by the server buffer. And once it's arrived at the server buffer, an acknowledgement is sent back, and we're good. Notice message 2 has not arrived to the server buffer, so we don't have an acknowledgement back. But message 3 and 4 have somehow made it along the way, and the acknowledgements have come back. Now, message 1 will be played to the operation, so it'll be dispatched to the service. However, message 3 and 4 won't if we turn on order delivery. So what happens is, once message 2 successfully arrives and is acknowledged, then the client can clear out their buffer of these messages because all acknowledgments have been received. And the service will play message 2 and then 3 and then 4 in order, and clear the buffer here as well. And so the idea is that if you enforce order, you can see that I might be holding on to a buffer here for a period of time, and the default buffer is 8. And of course, as soon as the orderly delivery has arrived, it'll play those messages in that order to the service and clear the buffer, and it'll be reused for subsequent messages. That lasts for the duration of the proxy. So the proxy at the client will control the lifetime of this reliable session, but we'll just reuse the same buffer for that period. If anything happens to fault the server channel or fault the client channel, then basically these two buffers are destroyed, the session is destroyed, the proxy needs to be recreated, and a new session created. And that happens in a couple of cases, which I'll talk about in a bit. But the idea is, again, that there is a channel on the client and server and a reliable messaging buffer on both ends that manage this process. Now, the standards behind this, although they don't really tell platforms how to implement it, they do talk about the messaging between the client channel and the server channel and what those should look like. So the Web Service Reliable Messaging Committee, WSRM, was actually around long before the current official reliable messaging standard. So WS Reliability is a standard that OASIS created back in November 2004. But that reliability standard, I just want to point out, is not the one that's implemented in WCF, and nor should it be, because the standard for WS Reliability did not take into account things like policy, security, and how we stack all of our web service standards these days. And so there was a new standard committee created, Web Service Reliable Exchange, or WSRX, and that committee holds the WS Reliable Messaging, or WSRM, standard. The latest spec for that is August 2006, and it's getting closer to ratification or finalization. There's also a description for a policy, which basically means that your web service description language, your WSDL contract, includes information that says, hey, this service supports reliable sessions. And then that way, in an interoperable way, a Java client, for example, could consume your WCF service, WSDL, and know that it could send reliable messaging messages to your service and have it work. So WCF implements these latest and greatest standards as they are today, and of course, as the standards are finalized, updates to the platform will be available. So what are these messages then? Why the standard? The standard provides interoperability, and there needs to be a way to create a session and get a response with a session ID, to acknowledge messages as they've been received, to indicate we have sent the last message to the service so that it will not expect any more, and also to officially terminate the sequence, which is basically a one-way call to the service that says, I'm done at the client, which means you probably closed your proxy and intentionally ended the session, potentially. Now, an acknowledgement is returned with a sequence acknowledgement, letting the client buffer know at all times, which messages have I received, 1 through 10, 1 through 20, etc. And I'll show you that when we look at some output. But that acknowledgement, of course, is either returned with an HTTP response, so it kind of piggybacks on any of the HTTP responses that come back from the service, or if you're using TCP, which has its full duplex communication or two-way communication, then separate messages are sent back to the client channel that you don't even see, because remember, you're up at the proxy level. All you see is, I called an operation, did I get my response? But the channel layer might have other messages that go back and forth just to acknowledge that we have received what number of messages. Here's how it works. So basically, the client calls an operation on the proxy. The proxy calls create sequence to the service channel. The response comes back with a sequence identifier or a session ID. Then the operation actually gets called. So all you know is you called the operation and it got called. But there was a quick message exchange to establish a session. Now, after that, the operation response comes back, but with that comes a sequence acknowledgement if we're talking HTTP protocol. So the sequence acknowledgement will say, I've received message 1 of 1. And then operation response finally comes back to the client, so all you see is the intended response. And then with subsequent calls, again, those are sent directly to the service through the service channel buffer, of course, and acknowledgments will come back with the responses. And then, of course, when you're done and destroy the proxy, a message for last message is sent with an acknowledgement that says, hey, I know that you sent the last message. And then a terminate sequence message is sent. But that's all at the channel layer. You don't see that happening. Now, if this was one-way operation, then create sequence is still called and a sequence response with an ID is still provided, and then the one-way operation invoked, but there is not a response. So what happens instead is a sequence acknowledgement is sent back at the channel layer. So you don't see it, but there is a message sent back to indicate acknowledgement. And again, one-way operations are called, sequence acknowledgements are sent at the channel layer. Ultimately, when it's last message and terminate sequence, that means you close the proxy or that something else told the channel to shut down. Now, lastly, if we create a sequence and we're over TCP, most of the same messaging still happens. But it's possible that we're going to get separate sequence acknowledgments rather than the operation response being, rather than piggybacking on the operation response, it could be a separate sequence acknowledgment because it's TCP. So that gives you a visual on the flow of messages that happen, and I am going to show you a trace dump of that because it's just really cool to see. And just to sort of sum it up, one of the reasons that client proxies, whether they be Java or .NET, are able to know that we have a reliable session or a capability for that, and to know that we can send these interoperable messages, is because the web service description language, like I said, includes policy assertions for reliable messaging. And the information included in those policy assertions include inactivity timeout and acknowledgement interval information. So you can see here we've got this WSRM assertion, which would be inside the WSDL. And in the WSDL it would say that, you know, these are, I'm supporting this version of RM policy, and this is the inactivity timeout, and this is the acknowledgement interval. Now, these standards for including policy in WSDL are not finalized, they're not ratified, but they're still heavily used in many platforms today. And so WCF, of course, implements the latest that is known. And as these things evolve and do finally get ratified, then of course the latest and greatest will be available for us to use as well. And remember that it takes a while for all the platforms to catch up. So we've got another example here. What I want to show you is that same reliable messaging demo I showed you before. Let's go to the client and talk about tracing. And you know, I do have some labs in my book on reliable messaging that take you through step by step how to set up tracing, just so that you know. But I'm going to go through it briefly here. So there's a diagnostic section where you can enable performance counters in WMI, but in addition you can enable message logging, and I'm going to log the entire message at the service level and at the transport level. And I'm going to dump it to a listener, which is an XML trace listener, and I'm just going to give this a new number, so WSRM20. And then that way we have a fresh trace log, absolutely fresh. Okay? Now, what that's going to do, I'll show you in a moment. First, let's just run the example once again. And again, I'm going to turn on the TCP example so that we can simulate failure. And what I'm going to do is call send and let it be successful the first time. And then I'm going to call send, let's say one way. And I'm going to stop the trace, continue. It's going to retry, but I'll restart the trace. Eventually it's going to be successful, and it's going to send the third and fourth message. Now, I'm also going to do this again, only this time I'm going to stop the trace and I'm not going to restart it. But in the meantime, let me show you what we have traced so far. So I'm going to open up that new trace log, and this service log that we just dumped will give us an idea of the messaging that just took place. Remember, first I had a successful message, so we started with create sequence, and we got a response. And just so that we can see a little bit better here, let me go to the XML for that. I just want to give you an idea what is in the standard. Well, create sequence is basically a message body that says, I want to create a new reliable messaging sequence, and it offers an identifier to be used. Now, in terms of create sequence response, it will send back an identifier. Could be a new one, could be the one that was offered. But now there's a shared ID that can be used for each message, so keep that in mind. And then when a message is sent, what you'll see is that in the SOAP headers, there is a sequence identifier and a message number. The sequence identifier is part of the agreed upon session ID, so the channels can be correlated on both ends. And the message number is indicating this is message 1. And here we are sending message 1. Now, this is just another copy of message 1 because I'm tracing at the transport and service model level. But if I scroll down a little bit, we're going to see a sequence acknowledgement came back. And that sequence acknowledgement says which identifier, so which channel, and an acknowledgement range. So lower is 1, upper is 1. We received the first message. Buffer remaining refers to how many how many slots are available for incoming messages. So that way the client channel knows if we've already filled up that server-side buffer while we wait for orderly messages, if you remember my diagram. And that's important because it's important for the client not to flood the service with requests if the buffer's full. So it should wait until the buffer frees up a bit. It's a throttle. And rather than, go through the process of failing at the service and timing out there, it will hold it at the client for a bit. Now, let's go back to the messages here. Again, each send message is going to have a message number and a response which comes back with an acknowledgement. So in this final send message here, which I believe is the third one then, we're going to see that it's message number 3, and we're going to see, I'm just looking for the message ID. Yeah, so there's a message identifier. And then if we look at the message response, okay, so this is the actual response coming back with the sequence acknowledgement that says we've received a range of 1 to 2. So we've received the first 2 messages. Now ultimately we're going to have a acknowledgement of all 3 messages. Here it is, acknowledgement range, lower 1, upper 3. And then eventually there is going to be a message that says, hey, I'm sending the last message. So here it is, last message number 4. And really it's just a header that says, hey, this is the last message. That just tells the service it can tear down that channel. And then terminate sequence is just, again, it's a header that says, in this case it's a body that says, for this session ID, we're terminating the sequence. So it's part of the standard, and that's that. Now that was a successful play. Let's go to the example which failed, and you'll notice that it appears as red in the trace because there were some errors and retries. And so it's just calling attention to this particular series. But it still ended up terminating successfully somewhere down here. Now, what's going to happen in this case is we did create the sequence successfully, and we did send the first message and get an acknowledgement. But the second message, so let's actually take a look. You'll see there's 5 messages in a row there. The second message, message 2, is sent. So message number 2. And message number 2 is resent. And message number 2 is resent again. So there were these retries, message number 2, that came from that reliable messaging buffer until ultimately we got a sequence acknowledgement saying, yes, we got message number 2, thank you very much. Now it's time to send message number 3, and you see that here. Last message, terminate sequence, away we go. Now over here, back in my demo, I guess I never actually sent that second message, which TCP traces down, so we're not going to see at this point the failure. It takes a little bit of time for the failure to happen because, of course, there's 8 retries by default. So what we'll do is just let that run, and I'll go back and talk about some more things. The point of that discussion, though, was just to give you an illustration of the actual messages that do take place and the fact that they are interoperable. They're based on SOAP messaging extensions. So now let's talk about the features of reliable sessions. So there are several things you can configure, and the acknowledgement interval defaults to 2 milliseconds. What that is once the message arrives at the service, how long before the service sends the acknowledgement? So it's 2 milliseconds. The defaults are usually fine for that. Flow control refers to if the buffer is full at the service, and remember we get a message back indicating how much room is left in the buffer, then the client will hold off sending new messages in order not to time out at the service. Instead, it will hold them at the client until it, has room basically in the buffer. The inactivity timeout has to do with how long will the reliable session last before timeout. And I'll go through a demo of that shortly, so we'll come back to it. The max pending channels has to do with how many reliable sessions or requests for a new reliable session can queue before it will time out the request, and so, or reject the request. And the default is 4 pending channels. So you might want to configure that differently at the service. The max retry count is defaulting to 8 retries. And what that means is it will retry 8 times to send the message. If you want to configure that differently, you can do so. If you'd like to know sooner that there's a failure, for example. Max transfer size window has to do with the size of the buffer where we actually queue up messages in order to make sure we deliver in order. Because remember that original diagram I showed you had a buffer whereby if we didn't receive all the messages in the right sequence order, we held on to X number of messages until we had the order, and then we fire them off to the service or dispatch them. And lastly, do you want order delivery? And that's a feature. Now, I showed you a configuration earlier that only allowed us to set 3 things. Enabled, which turns on reliable sessions, ordered, which says do we want ordered or not, and inactivity timeout. But all these other features are only configurable if you use a custom binding. So in a custom binding, you can build an HTTP text-encoded binding, add security, of course, but I'm just simplifying here. And reliable sessions gives you the ability to touch the acknowledgement interval, turn on flow control, set the inactivity timeout, the max retry count for the client, the transfer window size for the buffers on each side at the client server, if you want ordered or not, and what are the pending channels that are allowed to queue. So you can see that I would need to use custom binding if I want access to any of these extended features. There are some other things that you care about as well. For example, if you want to make sure that you deploy your service contract. So let's say you have a contract that allows you to send chunks of large files in order. And so you basically sort of initialize the session, send several chunks in order, and then terminate the session. So you might want to require order delivery on the binding, in which case you can set this attribute on the interface, on the contract, that says, I require order delivery. And what that will do is make sure that when you host, your administrators can't accidentally host in a binding that doesn't have order delivery. So it's a great way to enforce that. Now, if for some reason you don't want to attach that to a particular contract all the time, but maybe in this particular implementation of the contract on this service we want order, then we can apply the same attribute to the service type and indicate which is the contract that we want the order delivery on. You can also apply it to the whole class, but that makes a little bit less sense because it's usually related to a particular set of operations that you want order. So I prefer when you design your contracts in this way and the actual interface has order delivery required, because typically that is a design into the contract. I'll show you that in the demo shortly. The other thing that you care about is, of course, retry attempts. So retries are really the heart and soul of reliable messaging in most respects, in the sense that it will retry sending that message buffer underneath in the channel layer, which you don't even see happening. You only know when it ultimately fails. Okay? So you don't see all the retries. You don't get notified of all the retries. It just happens. If the retries are not successful, then you'll find out. If you time out trying to retry, then you're going to find out. So by default, 8 retries are attempted. Your proxy is completely unaware of the retries in progress. And then once the retry count is exhausted, the session will fault. Ultimately, if the client can't communicate with the server channel will time out, and it will clean up that reliable session as well. Now there's a session identifier that is created for the reliable session, and you saw how that was done using the create sequence. So that unique session identifier is negotiated so that both sides agree on the same ID, and that's how they correlate the correct channel receiving the message and the correct buffers. So that session identifier is accessible through the session ID property. Now you may recall we did a webcast several weeks ago on sessions, and there's a session ID also created if you have a application session, if you turn on sessions for your services. That session ID is also a shared session ID that's generated, but it is done based on the reliable session if there is the presence of reliable session. So in other words, there's only one session ID, a primary session ID, that is used to represent the proxy session with that service channel. And so if you turn on reliable sessions, that identifier will be used. If you have secure sessions and you don't have reliable sessions, then that one will be used. And if you have just a transport session but no other session, then it actually is a different session ID on both sides because there is no correlation needed. The socket is the correlation, or the pipe. But in terms of reliable sessions, as soon as you enable reliable sessions, that session ID that is negotiated through create sequence is the one you will see here. Ultimately, all you care about is that you have a session ID, and it is unique, and it is the one that identifies this session on both ends. Now, the session timeout is governed by the inactivity timeout of the reliable session, but there's also this thing called a receive timeout on all the bindings. So that can be a little bit confusing. So I always recommend that you set the receive timeout as opposed to the reliable session timeout specifically. Because what will happen is the receive timeout defaults to 10 minutes for a session. If you want to increase it to 20 minutes because you'd like the sessions to last a little longer, giving someone a way to walk away from a machine and come back and still have coffee, have a coffee, come back to the machine, whatever, then you can ultimately do that. But if you govern it by the receive timeout, then that number will govern the application session timeout, the reliable session timeout, and ultimately the secure session timeout. Otherwise, the lesser of the two wins if you don't have an application session. So if I don't turn on sessions at my service, then if I set inactivity in reliable session to less than the receive timeout, then it will win. So it will time out faster. In other words, the server channel will fault, as will the client channel. Let's take a look at a couple of those things. So I'm actually going to do a few things here. One is you'll see that we did ultimately time out from our retries. So I had to let that go for a little bit so that we could actually see that failure. And just before I close down the service trace, I may as well just refresh that and show you what happened when we tried to retry indefinitely. So what you'll see here is we retried, 8 times, and then ultimately we faulted. Okay? And so that information, throwing the exception here is going to say something like we timed out, operation didn't complete, because ultimately it couldn't complete the retries and successfully send them a message. So that's all I wanted to really show you there, is that yes, we did retry 8 times. It took a little while to do. There was at least a period of a minute or so there that it attempted those retries, and then after that it's just giving up. Now, let's take a look at a few of those other things. So first of all, let's talk about requiring order delivery. If I require messages to be delivered in order, then what I can do is apply this delivery requirements require order delivery equals true. When I run the host here, you're going to see an error right now because one of my endpoints isn't using a binding that will support that. It says delivery requirements attribute. Oh, okay. I'm sorry. That's a different thing. Let me just stop that for a second. Because I have one of my endpoints here, I believe. Yeah. Let me just go back to my contract here. There's a couple of things on the delivery requirements, right? One of them is queued delivery requirements, and one of them is require order delivery. And so if queued delivery requirements is true, then it's going to require a queued binding. And if you put on require order delivery is true, then it requires a binding that will support reliable sessions that have order delivery. Hang on, I don't think this is compiled. Hang on. Oh, excuse me. Queued delivery requirements mode allowed. Okay. It specifies not allowed. I'm not sure why this is happening here. I've modified my I'm not sure what I've done to my sample here. Not talking about queued delivery today, but I must have something in here that I'm not seeing. So let me just take a closer look. I'm just going to go back to where I was. Yeah. Yeah, okay. So if I require queued delivery and I try to expose this on an endpoint that doesn't support it, then I'm going to get an exception for that. But that's related to queued delivery, and that was how I originally had this example configured. So unfortunately, I have a whole bunch of endpoints in here. There's a base endpoint for pipe, TCP, and also HTTP. And I've got a number of customized bindings for TCP, HTTP. So basically the different ways that I can enable or configure each of these bindings. So one of them is just plain NetTCP. This one is NetTCP with reliable messaging. This one is HTTP with reliable messaging. This one is HTTP with reliable messaging and security. This one is a custom pipe binding that enables reliable messaging, one of those here, and so on. So I think just, the nature of this particular sample is that I was putting together a whole number of endpoints to illustrate which ones will or will not support these delivery requirements. So if we just take a look at the expanded bindings, this is HTTP binding with reliable session false. That's not going to work. So obviously, need to enable reliable sessions in order for this to work. Secure reliable sessions just means that not only do I enable reliable sessions, but I also have a secure session, which is the default behavior, by the way. The NetTCP binding, the default NetTCP binding is actually not with reliable sessions enabled. However, this one has reliable sessions enabled and order delivery. The custom HTTP binding has reliable sessions, and it is enabled by definition because I include this reliable sessions section. And we've got NetTCP custom binding with reliable sessions just to show you how to do a custom binding for TCP transport as well. which has reliable sessions. So the only ones that, and this is just a custom TCP binding, so we're going to get rid of the ones that are just plain without reliable sessions. And we'll only keep the ones that have reliable sessions enabled, because I think I was just playing in this example before, therefore we have a few things going on. At any rate, this is a good sample to illustrate all of the different configurations. So let me just go ahead and finish that off. So I've got secure sessions, I've got, this is just plain TCP, so we don't really need that one. Okay. And so what I'm going to do is get rid of the endpoints that are plain. So TCP reliable sessions, HTTP reliable sessions, secure reliable sessions, those are all good. NetPipe custom reliable sessions is good. TCP custom reliable sessions is good. And that's that. So now I've basically enabled reliable session support for all, but we still have to deal with this queued delivery, which is my other test that I was doing. So let's just go ahead and turn off queued delivery. So basically, we won't allow queued delivery. And now it works. So sorry for taking you through that whole circle there, but I guess I had been playing with this example in between takes here and playing with the queued delivery aspect. So basically, queued delivery is something I'll talk about in the MSMQ webcast coming up, but requiring order delivery just means that I have to have a binding that supports reliable sessions. And if I turn off reliable sessions on any one of these guys, then it's going to fail to host the service as I expected to see the first time. Now the message is a little bit confusing because it says queued delivery requirements not allowed, and that has nothing to do with what we're actually requiring here. What we're requiring is ordered messaging, so the error message is a bit unintuitive, but other than that, it's correct. Now let's talk briefly about timeout, and this will be the last example here. So basically, we've got a reliable session here that right now has an inactivity timeout of 5 seconds at the service. So what I'm going to do is just run it, send a message. It's about to send the second message, so what I'm going to do is wait for 5 seconds before I click continue. And we'll continue from here, and it faults. Why does it fault? Because we timed out. And so what happens if I change this to inactivity timeout or receive timeout of 10 seconds? Well, it's actually going to take the lower of the two. So if I set this to 5 and I set reliable sessions to 10, it's still going to fail in 5 seconds, which you'll see. I didn't wait, so let's wait this time. 1, 2, 3, 4, 5. And there it goes. So you see that it takes the lesser of the two. Now, if I enabled application sessions, then it would actually time out based on the inactivity, or sorry, based on the receive timeout instead, because that would control the lifetime of the application session, therefore the reliable session. So it's actually more intuitive if you just always set the receive timeout, because then it's the overall timeout for the entire service. So let's go ahead and kind of wrap it up here. Couple things about that. Reliable sessions is a session. If an exception is thrown at the service instead of a fault, it will fault the session. And that will also cause the client channel to be torn down eventually, and therefore you will not be able to continue to use that proxy. You'll have to recreate a new proxy and a new session. So it's important to catch those exceptions and respond by recreating a new session. Now, if you're concerned about which messages arrived or didn't, you're not going to know which messages arrived or didn't because you don't have access to that channel layer. But what you will know is that for the duration of that proxy, something didn't get there. So maybe if you were sending a large image in parts, for example, then you would restart the send. you'd have to. Now, if all you're doing is using reliable sessions in order to get more reliability, but it's not really about the order of the delivery, it's just about did the message get there, then go ahead and enable reliable sessions, turn off order, and use it for the transient network disconnection if order doesn't matter. So when would you use this then? You would remove risks associated with hiccups in network connectivity, as I mentioned. You'd be able to confirm delivery of a message, in particular for one-way, to know that it got to the service. You can't guarantee that the message actually gets executed beyond that, but you know it got there. And that's good enough usually for one-way messages. You want durable reliability, you have to use message queuing, and we'll talk about that in the next webcast. So you can force ordered delivery of messages. You can actually create a lower level chunking channel. In fact, there is a sample on the NetFX site still for a chunking channel that actually uses reliable sessions and takes a large image, let's say, and sends it in chunks in a reliable session. And then the reliable session can end at the end of that, and so you're establishing a new session for each large image broken into parts, and then starting brand new again. And then that way, if it fails, you know that image failed, and you restart the send of the image. So you can do interesting things with low-level customized channels using reliable sessions. And this also allows you to get reliability across interoperable boundaries. So this is a good thing. So things to consider: remember that the exceptions can fault the channel. Try to remember your services should send faults instead of exceptions where possible. You're susceptible to timeouts, so you have to handle that problem too. If you have a 10-minute timeout and the user walks away from the machine, you might need to restart your session. So keep that in mind in your design. And there is a small amount of additional messaging overhead, of course. So in most environments, the trade-off is worth it because you're going to only pay the price to establish and terminate sessions and receive acknowledgments. But you are just to be aware of that. And then, of course, acknowledgments are received at the channel layer, so your proxy doesn't really know which message failed. Just keep that in mind, unless you create a low-level channel that you have control over that. And so for more information, I guess just a reminder, the code for today's demonstrations in general and for all these webcasts is at thatindigogirl.com. If you're looking for something specific and you don't see it, feel free to email because I do have lots of samples lying around and some of them just may not be part of that particular download. But everything I've shown you here today is there. And then, of course, I'll go to questions and answers. So I'll turn it back to Tracy and then I'll take a look and see if anybody has questions. Thanks for joining today.
Excellent. Thanks, Michelle. Now, just as a reminder, for more information, you can print a PDF of today's session. To do that, you just want to go to the File menu in your upper navigation bar. Now is a good time to submit your questions into the Q&A panel down at the bottom of your screen. You just want to type them in and hit the Ask button. Also, I'm going to be posting a survey here in just a minute. If you would all please take a moment to fill it out before you log off. We really do appreciate your feedback. As a reminder, for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcasts. You can go here to access this webcast, which will be available for download in about 24 hours. Now, if you have any webcast content ideas, something out there you want to see and you haven't yet, we'd love to hear from you. Just take note of this link here. And now here's the survey from our session today. Please follow the links provided to complete today's webcast evaluation. And Michelle, it looks like you have questions waiting there for you.
Yeah, I'll take a look at these. So one of the questions is, what do we have to install on a client workstation for application deployment in the case of N-tier applications where the service is hosted on some server? Okay, I'm just trying to follow this. Hang on. I mean to ask whether we would need .NET 3 or on the client machine. Oh, yes. Okay. So for reliable sessions, well, anyways, anything to do with WCF, if you're going to use some of these extended standards like transactions, reliable sessions, and so forth with the WCF service, then yes, you would need .NET 3 on the client in order to establish this. WCF in .NET 3 is the only platform today from Microsoft that supports these latest and greatest standards. If you want interoperability with some of the earlier standards, you can get away with .NET 2 with WSE 3. Does WCF have different buffers for one-way and two-way messages? No, it's the same buffer, and all messages just go to the buffer and fire forward. And so as soon as they arrive, they are played. So even using the 8 buffer limit, those messages are going to pass through pretty quickly unless there is a significant problem. Can reliable messaging be performed asynchronously? I assume the ordered attribute would have to be set to false for this to provide any value. Well, you know, the nature of reliable messaging is that we get an acknowledgement. So it's not going to be asynchronous at the channel layer. If you're asking, can I use an asynchronous client to an asynchronous proxy and consume a service that supports reliable sessions, the answer is yes. Is reliable messaging used extensively? So far we've done without it. Isn't it esoteric? Well, I would say this. There are a lot of places in the world that have potential interruptions in network connectivity all the time, and this does make it a little bit more reliable. If I'm building an enterprise distributed system and I want to increase the likelihood of messages arriving to my services downstream, even behind the firewall, then I may want to enable that level of reliability. But you're right, oftentimes just for the performance, in order to tweak every possible dime out of performance, people may not do that behind the firewall when they feel like their network is reliable enough. So that's really a judgment call based on the application. Now, when we talk interoperability and clients that are part of other customers and partners, there I see this as incredibly valuable. When we talk about HTTP requests to the web server from a client application, and you want to give an increased reliability between the client and the service, I think then we've got an incredible amount of usefulness. So there it's more common. And I think that's it for the questions. So thanks very much.
All right, and with that, I do want to extend a very special thank you to you, Michelle, for your presentation today and answering the questions we had come through the queue. Well, ladies and gentlemen, this is going to conclude today's session. I want to thank you again for joining us. You may now disconnect from the audio portion of today's presentation.